September 3rd, 1939. The North Atlantic, 200 miles west of the Hebrides, the British passenger liner Athenia steams through calm seas, carrying 1,418 souls, including 300 Americans fleeing the outbreak of war. In the cold depths below, Oberleutnant zur See Fritz Julius Lemp peers through the periscope of U-30, his finger poised over the firing button. He believes he's looking at an armed merchant cruiser. The torpedoes streak through the water. 112 people die in the explosion and chaos that follows. The Battle of the Atlantic has begun. But beneath the surface of these dark waters, another battle is already underway, one that German submariners don't yet understand, a technological war that will transform their boats from hunters into the hunted. In the opening months of the war, U-boat commanders operated with supreme confidence. They had learned their craft well. The Type 7 U-boat, the workhorse of the Kriegsmarine submarine fleet, was a marvel of German engineering. Displacing 760 tons on the surface, capable of 70 knots above water and 8 knots submerged, armed with 5 torpedo tubes and carrying 14 torpedoes, these boats represented the cutting edge of submarine warfare. Their captains were bold, experienced, and utterly convinced of their technological superiority. They had reason for confidence. In September 1939, Royal Navy commanders still remembered the devastating U-boat campaign of the First World War, when German submarines had nearly starved Britain into submission. Between 1914 and 1918, U-boats had sunk over 5,000 ships, totaling more than 11 million tons. The Kaiser's submarines had brought the British Empire to the brink of defeat. Now, in 1939, Germany's submarine fleet was back, and this time they had something their predecessors lacked: advanced technology, better tactics, and lessons learned from the previous war. But what the German submariners didn't know, what Korvettenkapitän Karl Dönitz and his U-boat command hadn't fully grasped, was that the British had spent the past 20 years developing a weapon specifically designed to hunt submarines. They called it ASDIC. The name stood for Anti-Submarine Detection Investigation Committee, though historians would later discover this was likely a cover story. The technology had actually been developed by the British Admiralty's Anti-Submarine Division starting in 1918, too late for use in the First World War. Through the 1920s and 1930s, while Germany was prohibited from building submarines under the Treaty of Versailles, British scientists at HMS Osprey in Portland worked tirelessly on perfecting this underwater detection system. ASDIC worked on a principle that seemed almost magical to those who first encountered it. A transmitter mounted in a dome beneath a ship's hull sent out pulses of high-frequency sound waves into the water. These sound waves, operating between 14 and 22 kilocycles, travelled through the ocean at approximately 500 meters per second. If the sound wave struck a submerged object, it reflected back as an echo. The time between transmission and echo reception revealed the range. The direction of the transmitter head when the echo was received showed the bearing. It was underwater radar, using sound instead of radio waves. The operator would hear the outgoing pulse as a distinct ping. If it struck a submarine, the returning echo would sound as a beep. By 1939, the Royal Navy had equipped nearly all of its destroyers with ASDIC sets. They could detect submerged submarines at ranges up to 2,000 meters. The British believed they had solved the submarine problem. Admiral Sir Charles Forbes, Commander-in-Chief of the Home Fleet, declared that ASDIC had made submarine attacks on convoys virtually impossible. The British Admiralty's 1937 assessment concluded that the submarine would never again be the menace it had been in 1917. They were catastrophically wrong, not because ASDIC didn't work, but because they had fundamentally misunderstood how it would be used in actual combat. The first U-boat commanders to encounter ASDIC had no idea what was happening. They operated on the tactics perfected by their predecessors in the Great War. Submerge during the day to avoid aircraft. Surface at night to recharge batteries, make transit and attack convoys. The diesel engines that powered them on the surface were far more efficient than the electric motors used underwater. A typical Type 7 could travel over 8,000 nautical miles on the surface, but only 80 miles submerged at 4 knots. In the early months of the war, from September 1939 through early 1940, German U-boats enjoyed what their crews would later call the first happy time. Operating with relatively few restrictions, attacking merchant ships with near impunity, they racked up impressive tonnage. In September alone, 41 ships totaling 153,179 tons went to the bottom. October saw 27 ships and 134,807 tons sunk. The U-boat arm was proving its worth. But German commanders were beginning to notice something strange. When their boats were forced to dive and operate submerged, particularly when escorts were present, they were being found with disturbing regularity. Korvettenkapitän Otto Kretschmer, who would become Germany's most successful U-boat ace with 47 ships sunk, experienced one of the first confirmed ASDIC detections in October 1939. His boat, U-23, was patrolling off the Scottish coast when a British destroyer suddenly altered course and began racing directly toward his position. Kretschmer, a careful and methodical commander, had been running silent, deep, and slow. There was no periscope wake to betray him, no noise from his electric motors. Yet the destroyer knew exactly where he was. The sound came first, a sharp metallic ping that resonated through the hull, then another, then another. The pings grew louder as the destroyer closed. Kretschmer's hydrophone operator reported the sounds with growing alarm. The destroyer was tracking them, perfectly following every evasive maneuver. Kretschmer took U-23 deeper, below 100 meters, rigging for silent running. The crew shut down everything non-essential. Men breathed shallowly in the stifling heat. The pings continued, relentless, mechanical, hunting. Then came the depth charges. The first pattern fell wide, but not by much. The underwater explosions created massive shock waves that slammed into the pressure hull. Light bulbs shattered. Cork insulation rained down. The boat shook like a terrier had grabbed it. Kretschmer waited, his boat hovering in the cold darkness, while the destroyer circled above. More pings, more depth charges. For 3 hours, the British warship hunted U-23 with mechanical precision. Only when the destroyer finally broke off the attack, possibly low on depth charges, did Kretschmer risk creeping away. When U-23 returned to Wilhelmshaven, Kretschmer filed a detailed report. The British had some kind of underwater detection device. It could track a submerged submarine with startling accuracy. The sound was distinctive, a ping that could be heard clearly through the hull. And it was terrifyingly effective. Similar reports began filtering in from other U-boat commanders. Kapitänleutnant Günther Prien, the hero of Scapa Flow who had daringly penetrated Britain's main naval base and sunk the battleship Royal Oak, reported being hunted by pinging British escorts. Kapitänleutnant Herbert Schulze of U-48 described being tracked for hours by destroyers that seemed to know his every move. The German naval intelligence began compiling these reports with growing concern. The technology was clearly real, but what was it? How did it work? And most importantly, how could it be defeated? The German submariners gave the phenomenon a name. They called it Pale-Jarrett location device. They knew the British were using sound pulses, though the exact mechanism remained mysterious. More concerning was the growing realization that this detection system fundamentally changed submarine warfare. Throughout 1940, as Germany conquered Norway, the Low Countries, and France, U-boat operations expanded dramatically. The fall of France in June gave Germany access to Atlantic ports at Brest, Lorient, La Rochelle, Saint-Nazaire, and Bordeaux. Suddenly U-boats could reach far out into the Atlantic without the long, dangerous transit around Scotland. They could strike at convoys in the mid-Atlantic beyond the range of British escorts and aircraft. This began what U-boat crews called the Second Happy Time. From July 1940 through March 1941, tonnage sunk climbed to staggering levels. In October 1940 alone, U-boats sank 352,407 tons of shipping. The Wolfpack tactics that Dönitz had developed were proving devastatingly effective. Multiple submarines would converge on a convoy, attacking from different directions simultaneously, overwhelming the escorts. But here was the critical discovery that German commanders were making. The Wolfpack tactics only worked when attacking on the surface at night. When U-boats attacked submerged during daylight, when British escorts could use their ASDIC, the results were far different. Submarines were being forced to break off attacks, they were being hunted for hours, and they were being sunk. By early 1941, Dönitz and his staff at U-boat headquarters had assembled enough intelligence to understand the basic principles of ASDIC. It used sound waves. It could only detect submerged submarines. It had a maximum effective range of about 2,000 meters, though accuracy degraded significantly beyond 400 meters, and critically, it could not detect submarines on the surface. This last point became the foundation of German anti-ASDIC tactics. If the British detection system only worked underwater, then U-boats would avoid being underwater when escorts were present. They would attack on the surface at night, using their superior surface speed and low profile to penetrate convoy screens. The diesel engines would give them the mobility to outmaneuver slow escorts, and in darkness, the escorts would be nearly blind, their ASDIC useless against surfaced boats. It worked brilliantly, at least initially. Through 1941, surface night attacks became the standard German tactic. U-boats would shadow convoys by day, staying just over the horizon. At nightfall, they would close at high speed, penetrate the escort screen, and attack from within the convoy columns. The boldest commanders, like Otto Kretschmer, would position themselves in the middle of a convoy and methodically torpedo ships on both sides, their conning towers nearly invisible in the darkness. British escorts, unable to use ASDIC against surface targets and lacking effective radar, could do little but race around hoping to spot a U-boat's wake or silhouette. The statistics told the story. In 1941, German U-boats sank 875 Allied merchant ships, totaling 4.3 million tons. The Battle of the Atlantic was reaching crisis proportions. Britain was losing ships faster than they could be replaced. Food and fuel stocks were dropping to dangerous levels. Winston Churchill would later write that the only thing that truly frightened him during the war was the U-boat peril. But the U-boat crews were learning something else about ASDIC, something that would matter terribly in the years to come. When they were forced to dive when circumstances made submerged operation necessary, the British detection system was becoming more sophisticated and more deadly. The hydrophone operators in U-boats, the men who listened to the sounds of the sea through their headsets, began to understand the characteristic signature of ASDIC. They could hear it coming from miles away. The regular rhythmic pinging as British escorts swept their beams through the water. The pings would grow louder as the escort closed, and when a U-boat was locked by ASDIC, the pings became almost continuous, a mechanical heartbeat counting down to the depth charge, attack. The sound became the stuff of nightmares. Veterans would describe it decades later with shuddering precision. That metallic ping echoing through the pressure hull. The knowledge that somewhere above, a British operator was watching a flickering light on his range dial reading out numbers to his captain. Range closing, bearing steady, target confirmed. German engineers worked frantically on countermeasures. They developed buoy decoys, small devices that could be ejected from a submerged U-boat. The buoy would sink slowly, releasing a chemical that created clouds of bubbles. The bubbles reflected ASDIC pings, creating false targets and confusion. Sometimes it worked, often it didn't. The most effective countermeasure was understanding ASDIC's limitations and exploiting them ruthlessly. U-boat commanders learned that ASDIC performed poorly in rough seas. The turbulent water scattered and absorbed the sound waves. They learned about thermoclines, layers of water at different temperatures that could deflect or bend ASDIC beams. A U-boat diving below a thermocline might become effectively invisible to surface ships. They learned that ASDIC had a blind spot. From about 200 meters to the point directly beneath the attacking ship, the pulse and echo merged. The submarine disappeared from detection. This created a deadly game in the final moments of an attack. When the escort lost ASDIC contact and began its depth charge run, that was the moment of opportunity. A sharp turn to port or starboard, maximum power for 30 seconds, then back to silent running. Often the U-boat would escape the depth charge pattern, but sometimes it didn't. By late 1941 and early 1942, U-boat losses were climbing. In 1940, only 27 U-boats had been lost. In 1941, the number rose to 35. These were manageable losses. German shipyards were building submarines faster than they were being sunk. But the trend was ominous, and experienced commanders were starting to die, taking their irreplaceable knowledge with them. Then came a development that briefly tilted the balance back toward Germany. In February 1942, the Germans upgraded their Enigma cipher system by adding a fourth rotor to the machines used by U-boats. The British, who had been reading German naval communications through the Ultra program, were suddenly blind. For 10 months, from February to December 1942, the Allies could not decrypt U-boat communications. The result was catastrophic. Unable to route convoys around known U-boat positions, unable to anticipate Wolfpack formations, Allied losses skyrocketed. In 1942, U-boats sank 1,164 ships, totaling 7.8 million tons, the worst year of the war. The United States had entered the war in December 1941, but American coastal defences were woefully inadequate. U-boats operated with near impunity off the American East Coast in early 1942, sinking tankers and freighters within sight of shore. Captain Lieutenant Reinhard Hardigan in U-103 watched bathers on Long Island beaches while torpedoing ships silhouetted against the lights of New York City. This became known as Operation Drumbeat, and U-boat crews called it the American Happy Time. But even during this period of success, German submariners knew that ASDIC was evolving. British and Canadian escorts were getting better at using it. Operators were learning to distinguish between false contacts, whales, schools of fish, and actual submarines. Tactics were improving, the depth charges were falling more accurately, and most concerning of all, more and more escorts were being equipped with ASDIC. What had been a technology found mainly on destroyers was now standard on corvettes, frigates, and even converted trawlers. By mid-1942, the Battle of the Atlantic had become a desperate struggle between two learning organisations. German U-boats adapted tactics to exploit every weakness in Allied defences. Allied escort forces developed countermeasures to every German innovation. The technology race intensified. In September 1942, the British began deploying a new version of ASDIC, the Type 144 with what was called the Q attachment. This modified transmitter could direct sound beams at steeper angles, covering depths that earlier versions had missed. Submarines trying to hide in the deep were increasingly being detected. In November 1942, the Allies introduced the Hedgehog, a forward-throwing anti-submarine weapon that would revolutionize U-boat hunting. Unlike conventional depth charges dropped over the stern, Hedgehog fired a pattern of 24 small contact-fused projectiles ahead of the attacking ship. This meant the escort could maintain ASDIC contact right through the attack. No more blind spot, no more last-second evasion opportunity. When Hedgehog's projectiles hit, they killed. The statistic was damning. Conventional depth charges sank a U-boat only 4 to 6% of the time. Hedgehog achieved a kill rate over 20%. For U-boat crews, the technology meant that being detected now carried a much higher probability of death. December 1942 brought another hammer blow to Germany. British cryptanalysts at Bletchley Park broke the four-rotor Enigma. The Allies could once again read German naval communications. Convoys could be routed around U-boat patrol lines. Wolfpack formations could be anticipated and attacked. Support groups, flotillas of escorts not tied to specific convoys, could be dispatched to hunt U-boats in areas where German signals intelligence indicated submarine concentrations. The convergence was beginning. Better detection through improved ASDIC, better weapons through Hedgehog and new depth charge patterns, better intelligence through ultra-decrypts, better air coverage as very long-range aircraft began closing the mid-Atlantic air gap where U-boats had previously operated beyond aircraft range, and better training as escort commanders learned from experience and shared lessons. The U-boat force was running out of places to hide. The German response was to throw more submarines into battle. By early 1943, U-boat strength reached its peak. Over 400 boats were operational. At any given time, 100 or more were at sea. Dönitz believed that sheer numbers could overwhelm Allied defences. If he could maintain enough boats on station, they could sink merchant ships faster than the Allies could replace them. The theory had merit, but it depended on U-boats being able to find and attack convoys successfully. March 1943 saw the largest convoy battles of the war. The battle for convoys HX 229 and SC-122 in mid-March involved 38 U-boats attacking 90 merchant ships protected by increasingly capable escort groups. The Germans sank 22 ships. It seemed like a great victory. But the German losses, 12 U-boats in March alone, told a different story. Something fundamental had changed. Allied escorts were no longer simply reacting to U-boat attacks. They were hunting submarines aggressively. ASDIC operators had become expert at their craft. They could detect submarines at maximum range and track them through evasive maneuvers. They understood the water conditions that affected performance and adjusted their search patterns accordingly. They could distinguish between the acoustic signature of a submarine and the myriad other objects in the ocean that produced echoes, and they were ruthless. When contact was made, multiple escorts would converge. One would maintain ASDIC contact while others maneuvered to attack positions. Hedgehog patterns would be fired. Depth charges set to multiple depths would saturate the area. The attacks would continue for hours if necessary. U-boats that once might have escaped were now being hunted to exhaustion and destruction. April 1943 brought some respite as many U-boats withdrew to refit. But the losses continued. 15 boats went down in April. The exchange ratio, the tonnage sunk per U-boat lost, was dropping alarmingly. In the early days of the war, a single U-boat might sink 100,000 tons or more before being lost. Now the average was dropping toward 10,000 tons per boat. The mathematics of attrition were turning against Germany. Then came May 1943, Black May, as it would be known in German naval history, the month that ended the U-boat threat forever. The month began with the battle for convoy ONS-5, a slow westbound convoy of 43 merchant ships escorted by British escort Group B-7 under Commander Peter Gretton. Over 50 U-boats were concentrated in the area. The convoy was detected on April 28th, and the battle raged for 6 days. The escorts fought brilliantly. Using ASDIC to detect and track approaching U-boats, they maintained an aggressive posture that never allowed the submarines to settle into comfortable attack positions. HF, DF, high-frequency direction. Finding equipment allowed the escorts to get bearings on U-boat radio transmissions. Support aircraft forced boats to submerge, and when U-boats did attack, they paid a terrible price. 13 merchant ships were sunk, but 6 U-boats were destroyed, with several others heavily damaged. The exchange ratio had shifted decisively, but ONS-5 was just the beginning. Throughout May, convoy after convoy fought off U-boat attacks with increasing effectiveness. The technology that British scientists had spent 20 years perfecting, the tactics that escort commanders had developed through bitter experience, the intelligence provided by breaking Enigma, and the sheer industrial capacity of Allied shipbuilding all converged in a single month. Convoy SC Duffin 30 in mid-May was attacked by over 30 U-boats. Not a single merchant ship was lost. 5 U-boats were sunk. The German submariners were stunned. How had this happened? The escorts seemed to know where every U-boat was. ASDIC contacts were being made at maximum range. Depth charge attacks were devastatingly accurate. Aircraft appeared whenever U-boats surfaced. It was as if the Allies could read German minds. In a sense, they could. The ultra-intelligence told convoy commodores where U-boat patrol lines were forming. HFDF gave bearings on every radio transmission. Radar, particularly the new centimetric radar that German equipment couldn't detect, found surfaced U-boats in conditions where they thought they were invisible. And ASDIC, that persistent mechanical heartbeat, hunted them beneath the waves. The statistics for May 1943 told the story with brutal clarity. 43 U-boats lost, over 1/4 of all operational boats. Only 58 Allied ships sunk, totaling 299,000 tons. The exchange ratio had collapsed. Germany was losing U-boats faster than shipyards could build them. And worse, they were losing experienced crews, the veterans who knew how to survive, how to fight, how to evade. On May 24, 1943, Grand Admiral Karl Dönitz made the most difficult decision of his career. He ordered most U-boats to withdraw from the North Atlantic. The campaign that had nearly starved Britain into submission was over. In his order to the fleet, Dönitz attributed the losses to the superiority of enemy location instruments. He specifically cited the surprise from the air made possible by new radar systems. But the U-boat crews knew the real story. ASDIC had finally fulfilled its promise. The mechanical ping that had seemed merely annoying in 1939 had become the sound of death by 1943. German engineers would attempt multiple countermeasures over the remaining years of the war. The schnorkel, a breathing tube that allowed diesels to run while submerged at periscope depth, reduced the need to fully surface. Anti-sonar coatings called Albrecht rubber tiles were applied to hulls to absorb ASDIC pulses, though production difficulties meant few boats received the treatment. More sophisticated buoyed decoys were developed. The Type 20 Electroboot, a revolutionary design with streamlined hull and massive battery capacity that could operate submerged for extended periods, was rushed into production. But it was all too late. The technological advantage had shifted irreversibly to the Allies. By the time the first Type Thuntiustus boats were operational in early 1945, Germany was collapsing. The boats never conducted effective combat patrols. The final statistics of the Battle of the Atlantic demonstrated the complete reversal of fortune. In 1943, after Black May, 238 U-boats were sunk. In 1944, another 245 went down. In the first months of 1945, 160 more were lost. Of the 160 U-boats built and delivered to the Kriegsmarine, 785 were destroyed. Over 28,000 German submariners went to sea during the war. More than 32,000 never returned, a casualty rate of approximately 75%, the highest of any branch of the German military. For comparison, Allied merchant shipping losses, while severe, were being replaced faster than they could be sunk. American shipyards alone produced over 2,700 Liberty ships during the war, standardized cargo vessels that could be built in less than 2 months. The industrial capacity that Germany could never match had won the tonnage war. But the human story of ASDIC's impact went far beyond statistics. For the men who served in U-boats, who experienced being hunted by that relentless mechanical ping, the psychological toll was devastating. Captain Lieutenant Herbert Werner, who survived the war as one of the few U-boat commanders to complete multiple combat patrols in 1944 and 1945, described the terror of ASDIC hunts in his memoir. The ping would start as a distant sound, almost musical. Then it would grow louder, more insistent, closer. The men would freeze in position, barely breathing, knowing that any sound might give away their position. The pinging would circle the boat, sometimes for hours, and then would come the depth charges. Werner described boats that were hunted for 12, 18, sometimes 24 hours continuously. Escorts would maintain contact through crew changes, refueling from tankers, even through storms that made the surface ships roll viciously. The ASDIC ping was constant, patient, mechanical, inhumane. Men cracked under the strain. Some boats returned to port with crews so psychologically damaged they could never sail again. German naval doctors recognized a condition they called U-boat neurosis, symptoms including paralyzing anxiety, violent nightmares, and physical collapse at the sound of pinging. The technology had broken not just boats, but men. For the Allied sailors who operated ASDIC, the experience was different but no less intense. These were often young men, teenagers sometimes, trained in a few weeks to operate equipment that represented the cutting edge of physics and engineering. They would sit in cramped compartments, headphones clamped over their ears, watching the flickering range dial, rotating the transmitter head degree by degree through the search arc. When they achieved contact, when that distinct echo came back indicating a submarine, they became the center of their ship's universe. Officers crowded around them. The captain demanded continuous updates. Range, bearing, classification, movement. Lives depended on their skill and judgment. The good operators, the ones with experience and instinct, could tell the difference between a U-boat and a whale from subtle variations in the echo. They could predict evasive maneuvers. They could guide their ship through hours-long hunts with patience and precision. And when the depth charges exploded, when underwater explosions created massive noise that obliterated all acoustic contact for minutes, they would patiently wait for their equipment to clear, then resume the hunt. Some operators kept score. The number of U-boats they had helped kill. They painted small submarine silhouettes on their ASDIC domes. They took pride in their expertise. But most simply did their job with grim determination, knowing that every U-boat sunk meant merchant ships that would safely reach port, that would deliver food to Britain, weapons to Russia, fuel to the armies fighting in Europe and the Pacific. There is a tendency in military history to focus on weapons, on technology, on hardware. But ASDIC's real impact came through the men who used it, on both sides. It represented a fundamental shift in naval warfare. For thousands of years, the ocean depths had provided concealment and protection. Submarines exploited this, becoming nearly invisible underwater. ASDIC stripped away that invisibility. It turned the ocean transparent. For the first time in history, a submerged vessel could be tracked, pursued, and attacked with reasonable probability of success. The psychological impact of this cannot be overstated. U-boat crews went from being hunters, striking from concealment with near impunity to being prey, hunted by an enemy who could follow their every move. The reversal broke the morale of the U-boat force. By 1944, many boats returned from patrols without having fired a shot, their crews spent simply from the stress of evading constant detection. After the war, Allied interrogators systematically debriefed captured U-boat commanders. These interviews, preserved in archives, reveal the German perspective on ASDIC's evolution. Kapitän José Erich Topp, who survived the war with 35 ships sunk and was one of Germany's most decorated submarine commanders, was remarkably candid. In 1939, we thought the British ASDIC was a curiosity, he said. It could find us sometimes, but we could evade it easily. By 1941, it had become a serious problem. We had to change all our tactics to avoid being underwater when escorts were present. By 1943, it had become deadly. There was no hiding from it. The operators had become so skilled, the equipment so refined, that being detected meant being killed. That was the transformation we never expected. We thought technology was static. We didn't understand that the British would improve it, perfect it, turn it into a war-winning weapon. Topp's assessment was echoed by virtually every German submarine commander interviewed. They had underestimated Allied technological development. They had assumed that the ASDIC of 1939 would remain the ASDIC of 1943. Instead, they faced Type 144 sets, Type 147 articulated transducers, hedgehog weapons, improved depth charges, centrometric radar, and perhaps most devastatingly, operators who'd been through the Western Approaches Tactical Unit training program. WWII, the tactical training school established in Liverpool, put over 5,000 officers through intensive courses between 1942 and 1945. Using wargames played on large floor maps, experienced escort commanders taught younger officers every known U-boat tactic and the counters to defeat them. They emphasized aggressive prosecution of contacts, coordinated attacks by multiple escorts, and most importantly the psychological warfare aspect of anti-submarine operations. A U-boat could be killed by depth charges, but it could also be killed by being hunted to exhaustion, by forcing it to remain submerged until batteries died, until air became unbreathable, until the crew's mental state collapsed. ASDIC made this possible. The technology kept the submarine trapped underwater where it was slow, nearly blind, and increasingly desperate. Some hunts lasted over 24 hours. Some U-boats, unable to surface, running out of battery power, their crews gasping in foul air, simply stopped moving and waited for the depth charges. The technology that had seemed like an interesting scientific achievement in 1918 had become an instrument of systematic extermination by 1943. There is a certain irony in ASDIC's history. It was developed too late for World War I. Throughout the interwar period, budget cuts and lack of urgency meant the technology advanced slowly. The Royal Navy believed submarines would never again pose the threat they had in 1917. This complacency meant that when World War II began, ASDIC was operational but far from perfected. Had the British invested heavily in ASDIC development through the 1930s, had they trained operators to higher standards, had they deployed it across the fleet more thoroughly, the Battle of the Atlantic might have been won in 1940 or 1941 instead of 1943. Thousands of merchant seamen might have survived. Millions of tons of supplies might have reached Britain earlier. The course of the war might have been different. But that is speculation. What actually happened was that ASDIC became the ultimate example of a war-winning technology refined through desperate necessity. Every engagement provided lessons. Every lost convoy drove improvements. Every U-boat kill validated the approach. By 1943, ASDIC had evolved from an interesting gadget to a mature weapons system operated by expert crews and integrated into a comprehensive anti-submarine warfare doctrine. The Germans never developed an equivalent. Their Gruppenhochgerät hydrophone system could detect ships by listening to their propeller noise, but it was passive only. It couldn't send out pulses. To actively locate targets, German submarines spent the war reacting to ASDIC rather than deploying their own active sonar. This asymmetry was fatal. Allied escorts could prosecute submarine contacts aggressively because they had ASDIC. German submarines had to evade, hide, run. They could never turn and fight underwater because they were blind while their opponents could see. If there is a broader lesson from ASDIC's impact on the Battle of the Atlantic, it is about the nature of technological warfare. Weapon systems exist not in isolation but as part of larger operational systems. ASDIC worked not because it was brilliant technology, though it certainly was sophisticated, but because it was integrated with effective tactics, skilled operators, supporting technologies like radar and HFDF, good intelligence through Ultra, adequate numbers of escort vessels, and sufficient industrial capacity to sustain losses while building more platforms. Remove any one of these elements and ASDIC becomes far less effective. The Germans understood this too late. By the time they had developed countermeasures like Schnorkel and Type VCT Electra boats, the window of opportunity had closed. The Allies had achieved such complete dominance that no technological fix could restore the balance. When U-boat crews first heard that mechanical ping echoing through their pressure hulls in late 1939 and early 1940, they couldn't have known they were hearing the sound of their defeat. It would take 4 more years, cost hundreds of thousands of lives, and consume thousands of ships. But from the moment ASDIC became operational, the outcome of the underwater war was inevitable. Technology had shifted the advantage to the hunters. For the Allied merchant seamen who sailed in convoys across the North Atlantic, who watched for torpedo wakes and wondered if their ship would be next, ASDIC represented hope. They couldn't see it working. They didn't hear the pings. But when a destroyer suddenly raced away from the convoy and began dropping depth charges, when the escorts reported a submarine contact and successful prosecution, the merchant crews knew that something was protecting them. That invisible shield, that mechanical ping bouncing through cold dark water, hunting the hunters, was saving lives. By the time Germany surrendered in May 1945, the Battle of the Atlantic had been decided for over 2 years. The last U-boat sunk by ASDIC detection was U-3 destroyed on April 6, 1945, just weeks before the war ended. U-320's commander, Captain Lieutenant Wolfgang Wolters, had been at sea since March, desperately attempting to reach British waters to attack invasion supply convoys. A British frigate detected him with Type 144 ASDIC off Scotland. The hunt lasted 3 hours. Hedgehog attacks finally broke the submarine's back. There were no survivors. It was a fitting end to the technology's wartime career. From the first uncertain detections in 1939 through the systematic campaign of 1943 through 1945, ASDIC had transformed submarine warfare. The ocean depths were no longer a sanctuary. The mechanical ping had made them a hunting ground. After the war, ASDIC technology formed the basis for all subsequent sonar development. The principles remain unchanged. Active sonar still uses pulses of sound to locate underwater objects. The frequencies have been refined, the signal processing has become digital, the displays are computerized, but the fundamental concept that British scientists developed in 1918 and perfected through World War II remains the foundation of anti-submarine warfare. Modern submarines are quieter, faster, and deeper diving than their World War II predecessors. But they still must contend with descendants of ASDIC, now simply called sonar. The technology that U-boat commanders learned to fear in 1943 continues to hunt submarines 7 decades later. For the men who lived through those years, who operate the equipment or fled from its searching pulses, ASDIC represented something beyond mere technology. It was the sound of modern warfare, mechanical, relentless, impersonal. It reduced combat to mathematics, ranges and bearings and echo signatures. It took the romance out of submarine warfare and replaced it with systematic industrial killing. The U-boats of 1939, emerging from their pens with crews singing and confident, sailing forth to hunt Allied shipping, represented the last gasp of war as individual combat, as skill against skill. By 1943, those same boats crept from port with exhausted crews who knew they were sailing to their deaths, not because they lacked courage or skill, but because the technology had turned against them. The ping meant they had been found, and being found meant death. This is perhaps the most lasting legacy of ASDIC's impact on the Battle of the Atlantic. It demonstrated that in modern warfare, individual heroism matters less than systems, less than industrial capacity, less than scientific advantage. The U-boat commanders of 1943 were often as brave and skilled as their 1939 predecessors, but they were facing better technology, better tactics, better training, and better intelligence. Courage couldn't overcome those advantages. In the end, the Battle of the Atlantic was won not by great naval battles, not by dramatic single combat between heroic commanders, but by thousands of anonymous operators sitting in darkened compartments, watching range dials, listening to echoes, guiding their ships toward underwater contacts, by scientists refining transducer designs, by trainers teaching new crews at tactical schools, by industrial workers building escorts by the hundred, by the grinding, unglamorous work of technological warfare. When the last U-boat surrendered on May 8, 1945, when German submariners surfaced their boats and hoisted black flags in accordance with surrender terms, they emerged into a world where the ocean was no longer their ally. ASDIC had seen to that. The ping had spoken, and the depths belonged to those who could see through them. The immediate post-war analysis conducted by both British and American naval intelligence revealed just how completely ASDIC had transformed the underwater battlefield. In July 1945, the Royal Navy's Anti-Submarine Warfare Division published a comprehensive assessment based on combat data from over 15,000 convoy escort missions. The numbers were stark. In encounters where escorts achieved ASDIC contact on submerged U-boats, the kill rate had climbed to 23% by 1944, nearly 5 times the rate from early war engagements. More significantly, even when attacks didn't result in kills, they forced U-boats to remain submerged for an average of 8 hours, depleting batteries and preventing attacks on convoys. The psychological impact was quantified through interrogations of the 5,000 German submariners held in prisoner of war camps. Medical officers documented that over 60% showed symptoms of what would later be recognized as post-traumatic stress disorder. The most common trigger, mentioned in hundreds of interviews, was the sound of metal striking metal, which reminded them of the ASDIC ping. Korvettenkapitän Peter Kremer, who commanded U-33 through multiple patrols and survived the war, described the progression of fear in his post-war memoir. The first time you hear the ping, it's just a sound. The second time, it's concerning. The third time, it's terrifying. By your 4th or 5th patrol, just the thought of that sound makes your hands shake. I've seen hardened men, veterans of a dozen patrols, break down crying when the pinging started. It wasn't weakness. It was the rational response to technology that could kill you, and you couldn't fight back against it. The British development of ASDIC variants for specific roles demonstrated how thoroughly they had mastered the technology. The Type 147 articulated transducer, deployed from 1944 onward, featured a flexible mounting that maintained optimal contact with the water, even in rough seas. Previous ASDIC sets suffered performance degradation when ships pitched and rolled in heavy weather, sometimes losing contact with submarines at critical moments. The Type 147 solved this problem through a gimbal-mounted dome that automatically compensated for ship motion. The impact was immediate. Winter operations in the North Atlantic, previously periods when U-boats could operate more freely due to rough seas disrupting ASDIC performance, became just as dangerous as summer hunting. Captain Lieutenant Wolfgang Luth, one of Germany's most successful commanders with 46 ships sunk, encountered the Type 147 system in December 1943 during a patrol west of Ireland. His combat report, filed after returning to base, revealed the frustration of German submariners facing improved detection. We dived to evade aircraft at 800 hours. Seas were running at force 7, conditions that should have made ASDIC ineffective. Within 10 minutes, destroyer achieved contact. Despite evasive maneuvers and sea state, contact was maintained for 3 hours. They fired hedgehog patterns with disturbing accuracy. We sustained minor damage from near miss. Only by running to 200 meters and finding thermocline did we escape. This should not have been possible in those sea conditions. Their equipment has improved dramatically. Luth's observation was echoed throughout the U-boat force. The technological advantage that German submariners thought might shift back in their favour as newer boats and equipment became available was instead moving further toward the Allies. For every German innovation, the British had a counter ready, often before the German innovation even reached operational status. The Albrick anti-sonar coating demonstrated this dynamic perfectly. German engineers had developed synthetic rubber tiles, approximately 4 millimeters thick, that could be applied to submarine hulls. The tiles contained thousands of tiny air-filled cavities that absorbed ASDIC pulses rather than reflecting them. In tank testing at the Kiel Research Facility, the coating reduced acoustic return by 15 to 30%, potentially making submarines much harder to detect. the first operational U-boat fitted with Albrick coating, U-11, sailed on trials in August 1944. The results seemed promising. ASDIC range against the coated submarine appeared reduced by several hundred meters. But there were problems. The coating was difficult to apply. It required specialized facilities and skilled workers. More critically, it was fragile. Depth charge near misses could tear it away in sheets. Normal wear from submerging and surfacing caused it to peel, and most devastatingly, the Allies had already developed centimetric wavelength ASDIC that made the coating far less effective. By the time Germany had solved the application problems and was ready to coat operational boats in early 1945, the war was nearly over. Only a handful of U-boats ever received the treatment, and none achieved significant operational success. The technological race had become a rout. Meanwhile, Allied anti-submarine forces were receiving equipment that represented quantum leaps beyond the ASDIC sets of 1939. The Type 147B, introduced in early 1945, featured what operators called a searchlight capability. Instead of sending out omnidirectional pulses, the transmitter could focus its acoustic energy into a narrow beam, like a flashlight beam in darkness. This concentrated beam achieved detection ranges up to 4,000 meters under ideal conditions, double the range of earlier equipment. For U-boats, this meant that escorts could now detect them before the submarines could even hear the escorts' propellers through their passive hydrophones. The tactical advantage was overwhelming. Kapitänleutnant Adalbert Schnee, commanding U-2511, one of the advanced Type 21 Electra boats, experienced this firsthand on his only war patrol in May 1945. The Type WWII represented Germany's last desperate attempt to regain underwater superiority. With streamlined hydrodynamic hulls, massive battery capacity allowing sustained underwater speeds of 17 knots, and hydraulic torpedo reloading systems, these submarines were theoretically capable of operating underwater indefinitely and outrunning surface escorts while submerged. U-2511 sailed from Norway on May 1, 1945, one of only two Type WWII boats to conduct war patrols. Schnee, an experienced commander with multiple combat patrols in conventional Type 7 boats, was eager to test the new submarine's capabilities against Allied escorts. On May 4th, while running submerged at 200 meters northeast of the Faroe Islands, U-2511's hydrophone operator reported faint propeller sounds. Schnee brought the boat to periscope depth to investigate. Before he could raise the periscope, the sonar operator reported ASDIC transmissions. But these weren't the familiar pings of conventional ASDIC. They were shorter, higher frequency, and stronger than anything he had encountered. The British cruiser HMS Norfolk, equipped with the latest Type 147B ASDIC, had detected U-2511 at 3,800 meters while the submarine was still unaware of the cruiser's presence. Norfolk turned toward the contact and increased speed. Schnee, realizing he had been detected, took the Type WWII deep and accelerated to maximum underwater speed. For the first time in the war, a U-boat could attempt to outrun surface pursuit while submerged. At 17 knots, U-2511 pulled away from the cruiser, which could make only 32 knots on the surface, but the ASDIC contact remained solid. Norfolk's operators tracked the fleeing submarine with ease, calling out ranges and bearings to their captain. Schnee tried everything. He varied depth from 50 to 250 meters. He turned sharply, attempting to break the acoustic lock. He reduced speed and ran silent. Nothing worked. The Type 147B system tracked him through every maneuver. After 2 hours, with batteries depleting despite their increased capacity, Schnee faced a choice: surface and risk attack or continue until batteries died completely. He was saved from the decision by a radio message. Germany had surrendered. The war was over. In his post-war interrogation, Schnee was candid about the experience. The Type WWII was everything we had hoped for: speed, endurance, handling, all superior to any previous submarine. But it didn't matter. Their detection equipment had advanced so far beyond what we faced in 1943 that our technical improvements were irrelevant. They found us immediately. They tracked us through evasive maneuvers that should have broken contact. If the war had continued, we would have died just like all the others. The Type WWII changed nothing. This became the final verdict on the technological war between U-boats and ASDIC. German innovation, even genuine breakthrough innovation like the Type WWII, couldn't overcome the systematic Allied advantage in detection, weapons, and tactics. The industrial and scientific infrastructure that had produced ASDIC was the same infrastructure that could rapidly improve it, deploy it fleet-wide, and integrate it with other technologies like radar, HFDF, and Hedgehog. Germany simply couldn't match this. The human cost of ASDIC's effectiveness became fully apparent only after the war when casualty figures were compiled. Of the 4,900 German submariners who served during the war, 2,744 died and 5,000 were captured. This 75% casualty rate exceeded that of any other military service in any nation during World War II. The Luftwaffe's bomber crews, flying over heavily defended targets, suffered approximately 50% casualties. British Bomber Command, which endured horrific losses in the strategic bombing campaign, lost 44% of aircrew. Soviet infantry units, fighting on the Eastern Front in conditions of unimaginable brutality, suffered casualties around 60%. But U-boat crews exceeded them all, and the primary killer, accounting for more U-boat losses than any other cause, was the combination of ASDIC detection and depth charge or Hedgehog attack. Of the 785 U-boats lost during the war, 288 were sunk by surface ship depth charge or Hedgehog attacks guided by ASDIC. Another 245 were destroyed by aircraft, many of which used ASDIC's airborne equivalent, air-to-surface vessel radar, to achieve detection. The technology and its variants accounted for over 65% of all U-boat losses. For comparison, mines accounted for 52 U-boats, accidents claimed 48, and only 20 were lost to submarine-on-submarine combat. ASDIC was the dominant killer. The individual stories of U-boats destroyed by ASDIC-directed attacks revealed the brutal efficiency of the technology by war's end. U-415, commanded by Oberleutnant zur See Kurt Nedy, provides a representative example. On July 14, 1944, U-415 was operating submerged in the English Channel, attempting to attack the continuing flow of invasion supplies to Normandy. The Channel was among the most dangerous patrol areas in the world by this point, saturated with Allied escorts, aircraft, and patrol craft. At 14:20 hours, HMS Bickerton, a captain-class frigate equipped with Type 144 ASDIC and Hedgehog, detected U-415 at 1,600 meters. The frigate's commanding officer, Lieutenant Commander William Aubrey Pardo Thomas, was an experienced anti-submarine warfare officer who had completed the Western Approaches Tactical Unit course. He began a textbook prosecution. Bickerton closed the contact, transmitting continuous ASDIC pulses. Need, hearing the pings through his hull, attempted to evade. He took U-415 deep, to 180 meters, near the submarine's maximum operating depth. He altered course 90 degrees to port. He reduced speed to minimize noise. The ASDIC contact never wavered. Pardo Thomas maintained perfect tracking, adjusting his ship's course to match every German maneuver. At 800 meters range, he reduced speed and brought Bickerton's bow to bear on the submarine's position. At 300 meters, he fired a full 24-round Hedgehog pattern. The projectiles arced through the air and entered the water in an oval pattern 40 meters wide. They sank at 7 meters per second toward U-415's position 180 meters below. At 14:24 hours, 3 Hedgehog projectiles detonated simultaneously. The contact-fused weapons had struck U-415's pressure hull. The explosions tore through the submarine's control room and forward torpedo compartment. Water flooded in under massive pressure. U-415 went down in less than 30 seconds. There were no survivors from the 51-man crew. The entire engagement, from initial detection to sinking, lasted 4 minutes. This was anti-submarine warfare in 1944. Clinical, efficient, deadly. The ASDIC operator's skill, the commander's tactical judgment, and the Hedgehog's lethality combined to destroy a submarine before its crew even understood they were in mortal danger. No prolonged hunt, no extended depth charge attack, just detection, prosecution, and death. The efficiency was repeated hundreds of times in 1944 and 1945. U-415 on August 20th, 1944. Detected by ASDIC, sunk by Hedgehog in 7 minutes. U-1003 on March 23rd, 1945. Detected, prosecuted, destroyed in 12 minutes. U-22336 on May 4th, 1945. 11 minutes from detection to sinking. The learning curve that had taken British escorts from 1939 to 1943 to climb had been thoroughly mastered. By war's end, newly commissioned escort crews were achieving kill rates that veteran groups from 1942 would have considered impossible. The training infrastructure, particularly the Western Approach's tactical unit, had systematized the knowledge that early war pioneers like Commander Frederick John Walker had developed through combat experience. Walker himself, the Royal Navy's most successful anti-submarine warfare commander with 25 U-boats sunk or shared credit, had been instrumental in developing ASDIC tactics. His innovation of the creeping attack, where one escort maintained ASDIC contact while directing another escort to attack from a different angle, multiplied the effectiveness of escort groups. Walker's tactical doctrine, refined through dozens of engagements from 1941 through 1944, became the standard taught to all escort commanders. His emphasis on aggressive, sustained prosecution of contacts, on maintaining attacks for hours or even days if necessary, on working in coordinated groups rather than individually, transformed anti-submarine warfare from reactive defense to offensive hunting. Walker died of a stroke in July 1944, worn out by the strain of continuous operations. He was 48 years old. But his legacy lived on in every ASDIC-equipped escort that sailed thereafter. The tactics he pioneered, combined with the technology he had helped refine through operational testing and feedback, became the standard that destroyed the U-boat force. The German response to this systematic destruction became increasingly desperate. In late 1944, Dönitz proposed Operation Caesar, a plan to deploy U-boats equipped with experimental Steinbutt acoustic homing torpedoes in coordinated attacks on Allied convoy routes. The Steinbutt torpedo could detect ASDIC transmissions and home on them, theoretically turning the Allied detection system into a vulnerability. The idea had merit. If U-boats could fire torpedoes that would automatically seek out and destroy ASDIC-equipped escorts, the technology that had dominated the battle could be negated. Testing at the Eckernförde Torpedo Development Facility showed promising results. The Steinbutt could detect ASDIC pulses at ranges up to 1,500 meters and would steer toward the transmitting ship. But operational deployment revealed fatal flaws. The torpedo's homing mechanism was disrupted by depth charges, which were invariably being dropped once ASDIC contact was achieved. The acoustic seeker couldn't distinguish between friendly and enemy vessels, leading to fratricidal attacks, and most critically, Allied escorts began using ASDIC intermittently, rather than continuously, once intelligence revealed the German acoustic homing capability. A few pings to achieve contact, then silence while closing to attack, meant the Steinbutt torpedoes lost their targets. Of the 40 Steinbutt torpedoes fired in combat, only 2 achieved hits. Neither sank their targets. The technology that was supposed to counter ASDIC instead demonstrated how thoroughly the Allies had adapted to every German innovation. By early 1945, U-boat commanders faced an impossible strategic situation. Attacking meant being detected meant being hunted meant death. The only rational tactical choice was to avoid contact entirely, but avoiding contact meant failing to accomplish the mission of sinking Allied shipping. The U-boat force had been rendered strategically irrelevant. Captain zur See Reinhard Hardigan, who had wreaked such havoc off the American coast in 1942, summed up the situation in a March 1945 briefing to new commanders. Your mission is impossible. The enemy can find you anywhere, at any depth, in any sea state. Their detection equipment is superior to anything we have. Their weapons are more effective. Their tactics are more refined. You will be found. You will be attacked. Most of you will die. The only question is whether you sink any ships before that happens. Most of you won't. This brutal honesty, which would have resulted in court-martial earlier in the war, was by now simply accepted truth. Hardigan himself refused further combat commands, taking a training position instead. He survived the war. Most of the commanders he briefed did not. The final U-boat loss of the European war occurred on May 7, 1945, hours before the German surrender took effect. U-2336, a type of Byth III coastal submarine, was detected by ASDIC off the Firth of Forth in Scotland. HMS Redmill, a Castle-class corvette, prosecuted the contact with Hedgehog. The attack was successful. U-2336 went down with all hands. The war that had begun with Lemp's attack on Athenia ended with an anonymous submarine destroyed by the technology that had dominated the conflict. The British ASDIC operators who achieved that final kill likely never knew they had bookended the Battle of the Atlantic. In the immediate post-war period, both British and American navies conducted extensive trials, with captured German submarines to validate their understanding of ASDIC's effectiveness. U-2513, a type Voskhus captured intact, was sailed to the United States and subjected to intensive testing. American destroyers and destroyer escorts equipped with the latest ASDIC equivalents, which the US Navy called sonar, hunted the submarine under conditions simulating combat. The results vindicated Allied confidence. Even with the type Thesiofin's superior underwater performance, even with experienced operators trying every known evasion tactic, the submarine was detected and tracked successfully in over 90% of simulated engagements. The few times it escaped detection involved unusual oceanographic conditions, specific thermoclines, or extreme depths that would have been tactically useless in actual convoy battles. The conclusion was unavoidable. ASDIC had permanently altered the submarine surface-ship balance. Submarines could no longer rely on submersion for invisibility. The ocean had become transparent. This realization shaped post-war submarine development in both Western and Soviet navies. If detection was inevitable, submarines needed to become faster underwater to outrun pursuers, deeper diving to operate below ASDIC range, and quieter to reduce their acoustic signature. These requirements drove the development of nuclear propulsion, high-strength steel for deeper diving hulls, and sophisticated noise reduction systems. The modern submarine emerged directly from the lessons of ASDIC's dominance in World War II. Similarly, ASDIC's success shaped anti-submarine warfare doctrine for the next 50 years. The principles established in the Battle of the Atlantic, continuous active transmission, coordinated attacks by multiple platforms, integration with other sensors like radar and magnetic anomaly detectors, and aggressive prosecution of contacts, remained standard through the Cold War. Soviet submarines in the 1950s through 1980s faced essentially the same challenge that German U-boats had faced in 1943, how to operate effectively when the enemy could detect you wherever you went. The technology became more sophisticated. Digital signal processing replaced analog displays, computer-aided tracking replaced manual plotting, variable depth sonar allowed transmitters to be lowered below thermoclines, towed arrays provided long-range passive detection, but the fundamental concept remained unchanged from what British scientists had developed in 1918 and perfected by 1943. In 1982, during the Falklands War, the British nuclear submarine HMS Conqueror used modern sonar, the direct descendant of ASDIC, to detect and track the Argentine cruiser General Belgrano. The subsequent torpedo attack and sinking demonstrated that the technology first used to hunt U-boats was still effective 4 decades later. In 1988, the US Navy's oceanographic research revealed just how sophisticated Allied ASDIC operations had been during World War II. Analysis of North Atlantic water conditions showed that British operators had empirically discovered principles of ocean acoustics that weren't formally understood until the 1960s. The way experienced ASDIC operators adjusted their search patterns based on water temperature, salinity, and depth anticipated scientific understanding by decades. They didn't know the physics. They just knew from experience that ASDIC worked better under certain conditions and worse under others. This practical knowledge, passed from veteran operators to trainees, encoded in tactical manuals and training programs, represented accumulated wisdom that took years to develop. It was this operational expertise, as much as the hardware itself, that made ASDIC so deadly. The German submariners never developed equivalent expertise because they were always on the receiving end, always reacting, never able to experiment systematically with their own active sonar systems. The oral histories collected from surviving U-boat veterans in the decades after the war provide a consistent narrative. The technology terrified them. Not the abstract concept of detection equipment, but the specific experience of hearing those pulses through the hull, knowing that each ping meant someone above was watching a display, reading out numbers, preparing to kill them. Oberleutnant zur See Horst Bredow, who survived the sinking of U-864 by British submarine HMS Venturer in February 1945, the only instance of one submerged submarine sinking another using sonar, described the experience in a 1972 interview. You could hear them hunting, not just the pinging, but the propellers of the enemy submarines circling, searching. We were trying to stay silent, but they found us anyway. When the first torpedo detonated against the hull, I was blown through a bulkhead. The boat went down in seconds. I made it to the surface, I don't know how. Of the 73 men aboard, only 5 of us survived. That sound, those pings, I hear them still in nightmares. For the Allied sailors who operated ASDIC, the post-war years brought a different kind of reflection. Many struggled with the knowledge that their technical expertise had killed thousands of men. The abstract nature of ASDIC operations, watching displays and calling out numbers rather than seeing the enemy face to face, didn't make the killing easier for everyone. Sub-Lieutenant Peter Gretton, who operated ASDIC on multiple escorts during the war, wrote in his memoirs about the moral complexity of the technology. We celebrated when we sank a U-boat. There would be rum, issued, congratulations all around. But sometimes I would think about the men inside that submarine, drowning in darkness, crushed by pressure, burning in oil fires. Boys really, most of them younger than me. We killed them with sound waves and mathematics. It seemed so clean, so scientific. But they died just as horribly as anyone in war. The technology made it easy to forget they were human. This tension between the clean efficiency of technological warfare and the bloody reality of death would become a defining characteristic of modern combat. ASDIC represented one of the first examples of remote killing, where the operator never saw the target, never witnessed the destruction, only observed symbols on displays and listened to echoes. The ASDIC era in anti-submarine warfare officially ended in the 1960s, when the term was replaced globally by sonar, sound navigation and ranging. But the principles, tactics and lessons remained. Every modern submarine knows that operating underwater means being potentially detectable by active sonar. Every surface ship knows that hunting submarines requires sophisticated acoustic sensors and weapons. The balance established in the Battle of the Atlantic between submarines trying to hide and surface ships trying to find them continues in the depths of today's oceans. The final assessment of ASDIC's impact must acknowledge both its tactical effectiveness and its strategic significance. Tactically, it was the single most important anti-submarine technology of World War II, directly responsible for more U-boat kills than any other weapon system. Strategically, it ensured Allied victory in the Battle of the Atlantic, which in turn ensured that Britain stayed in the war, that American and Canadian supplies reached Europe, that the build-up for D-Day proceeded, and that the Western Allies could prosecute the war to victory. Without ASDIC, the U-boat campaign might have succeeded. Britain might have been starved into negotiated peace. The course of history would have been different. When Oberleutnant Fritz Julius Lemp fired the torpedoes that sank Athenia on September 3, 1939, he set in motion a technological war that his side would ultimately lose. The U-boats that seemed so formidable in 1939, that brought Britain to the edge of defeat in 1941 and 1942, were by 1943 swimming into a killing zone created by ASDIC. That mechanical ping, dismissed by early U-boat commanders as a nuisance, became the sound of their annihilation. The ocean depths that had protected submarines for decades became transparent, and 28,000 German submariners paid with their lives for the lesson that technological superiority once lost cannot be regained through courage alone.